many purposes, we require a metal with greater strength than iron. So iron is made into steel. 15 tons of hot steel. Now it must be given a shape which we can handle, such as this. The scale must be cleaned off. Then a reheating furnace prepares the slabs for the rolling mill. A cascade of water cools the rollers, jets of steam blow the scale away, and the slab sets off on its half-mile journey down the rolling mill to become sheet steel. We need a substance relatively cheap, easy to apply, just as easy to remove again. There is such a substance. It is oil. A film of oil protects metal from corrosion merely by forming an unbroken barrier between metal and air. But we can do even better than that. This oil has been reinforced for the job. It contains an additive known as a corrosion inhibitor. It will actively protect iron and steel from rust. Snug in a coat of oil, the coil is ready to be dispatched to a factory. The enemy has been repelled, but he lays siege. He will always be waiting. This is only the beginning of the battle. It can be fought during the process of manufacture. Coils of sheet steel in storage are still protected by the coat of oil they received at the steelworks. On the flexing and shearing machine, the curvature of the metal is removed, and the steel is cut into manageable shapes for the pressing lines. Another coat of oil is applied to remove any dirt picked up on the journey. This oil takes over the job of protecting the metal. The machine itself is also lubricated and protected by oil. Metal and oil now face the ordeal of the pressing lines. The press is hydraulically assisted. Enormous pressures are exerted on the steel sheet. Some areas are heavily stressed. Hydraulic oil protects precision parts of the press from corrosion. Drawing lubricant protects the areas of the sheet which will be most heavily stressed. These areas become vulnerable to corrosion, and the drawing lubricant acts as a corrosion inhibitor. Flame welding, spot welding, and automatic welding. All these processes remove some of the protective oil. But at this stage, the corrosion inhibitor is speed. Considerable investment in man-hours and materials. In the body assembly plant, it has been buffed and scraped, and some of its protecting oil has been removed, and some of it has been burnt by welding. Where this has happened, the way is open for the enemy to strike. These bodies are not only valuable, but also vulnerable, and no time must be lost in moving them on to the paint shop. Before any paint can be put on the bodies, the remainder of the oil must be removed under high-pressure jets of water. This is followed by a hot alkaline rinse, another water rinse, a phosphate rinse, more water, a chromate rinse, and finally a rinse in demineralized water before the shell is dried under a blast of hot air. The body has then received its initial bonding. One of the problems which has to be dealt with in the production of the modern car is how to protect inaccessible places, such as inside the doors and box girders, from corrosion. The modern solution is electrocoating, a process similar in many ways to electroplating of metals. The bodies are totally immersed in a tank containing a solution of paint particles finely suspended in water. The paint particles and the walls of the tank are negatively charged. The car body is positively charged. The paint particles are deposited on the steel shell of the car, and even the most inaccessible places are coated in this way. The complete process takes 3 minutes, the time it takes for a body to travel through the tank. Although a more expensive process than other methods used, it has proved its worth by giving better protection against corrosion. Next, a grey undercoat is applied, and the bodies emerge from the drying ovens. The basic work of protection has been done. Now, any joins between panels on the underside of the car or in the boot must be sealed with a black rubberized compound. This is to prevent leaks which could lead to corrosion along the joins. The final coats of paint are applied in an air-conditioned tunnel. Every particle of dirt and dust must be removed from the air so that no blemish spoils the finished surface. These final coats are not just a pretty finish. They are thin but effective bulwarks against the enemies of steel, air and water. At the end of the tunnel, each body is minutely inspected for blemishes on the paintwork. The slightest fault is enough to send it back down the line. As they're passed by the inspectors, the bodies are shunted, maneuvered, and parked in lines. Sheet steel, at first coddled in oil from steelworks to assembly plant, now permanently cocooned in a gleaming layer of paint. The next stop is the final assembly line, where the painted shell will become a completed motor car. But what is a car without an engine? That is another part of the story. In the foundry, the engine begins its life as a liquid, molten iron. Bonded sand is used to make the molds which form engine components. The molds must be heated to remove any moisture which would cause an explosion if molten metal were poured onto it. Here, grey cast iron makes cylinder blocks, cylinder heads, and gearbox casings. Nodular iron is used for rocker arms, steering components, and crankshafts. After pouring, the metal is left to solidify before being broken out of its mold. Now the sand must be removed on the vibrator. Components subject to violent mechanical motion present critical lubrication requirements. Oil here, as on every machine in the factory, is performing the dual task of lubrication and corrosion prevention. The castings are now ready for initial machining. High spots are removed by grinding. The village blacksmith started all this, but now times have changed. Under the 2,000-ton press, steel is forged into crown wheels. Gear wheel blanks, connecting rods, axle shafts, and steering components are also forged. This machine is forging half shafts. Once the cooling fluid used was water. Then it was discovered that time was being wasted changing the dyes which had rusted in. Now an emulsified oil is used. In the finishing shop, raw castings and forging